Today we're going to be detectives. We're on the case of a medical mystery, a really crucial piece of data that seems to have just vanished from a standard lab report. So what happened? Let's find out together.
It's a weird question, I know. I mean, we expect these documents to be jam-packed with information, right? But sometimes what isn't there tells the most important story of all. And believe me, this is one of those times.
Okay, so let's dive right into the evidence. What you're looking at is a table from the Clinical and Laboratory Standards Institute, or CLSI for short. It's basically a guide for testing bacteria like Haemophilus influenza. Now I want you to look at the line for the antibiotic Amoxicillin-clavulanic. See it? For one of the most common test methods, the disc diffusion test, the data is just gone. A blank space where a critical number is supposed to be. So what's going on here?
And just to be clear, this was no accident. This slide confirms it. The CLSI's official stance is crystal clear. For the bacteria H. influenzae, they provide criteria for one type of test. That's the MIC test, but they explicitly withhold it for the disc diffusion test. This was a deliberate choice, a conscious decision, and we are going to get to the bottom of why.
Our investigation really kicks off in 2022. That's when a major update to medical standards was released. And this, my friends, is our very first real clue to solving the mystery of the missing breakpoint.
So what exactly changed? Well, the CLSI lowered the official breakpoint for this antibiotic. A breakpoint is just the concentration of a drug you need to actually stop bacteria from growing. So by lowering that number, they're essentially saying the antibiotic had to be effective at a lower dose. It made the standard for what's considered susceptible a whole lot stricter.
And the reason for this change gets right to the heart of patient care. Brand new data, specifically on how a drug moves through and acts on the body, showed there was a problem. Standard oral doses just weren't reliably strong enough to kill bacteria at that older, higher concentration. So to make sure treatments would actually work, the standard had to change. It was a safety thing. Now, to really understand what happened next, you need to know the two main characters in our story. First up, you've got the MIC test. You can think of this one as the gold standard. It's incredibly precise. It tells you the exact minimum concentration of a drug needed. Then you have the disc diffusion test, which is more like a quick estimator. It's faster, it's more common, but, and this is key, it totally relies on being accurately calibrated to that gold standard. And this is where the plot really starts to thicken. Because when the gold standard changed, its relationship with our quick estimator completely fell apart.
This timeline lays it all out perfectly. Before 2022, everything was fine. The MIC and disc test data were lined up. Then, new studies came out and revealed a potential weakness in treatment. So in response, the CLSI lowered the MIC breakpoint in 2022, updating the gold standard to protect patients. And here it is, the crucial consequence. The old disc diffusion measurements, our quick estimator, well, they just couldn't be trusted anymore to predict this new, stricter standard. The link between them was completely severed.
And the smoking gun is right here, in the CLSI's own words. When they made the update, there just wasn't enough new research to, remap the results from the quick disc test to the new, more accurate MIC breakpoint. The old correlations were suddenly invalid, and new ones hadn't been figured out yet.
This whole situation highlights a core principle in science and medicine, and it is so important. No data is better than bad data. Seriously. Leaving the old, misleading information could have led doctors to choose the wrong antibiotic, and that would put patients at risk. So to prevent that, the CLSI made the tough but absolutely correct call. They removed the data, wiped it clean.
So, you're probably wondering, okay, so how do labs even deal with this missing data? And that's a great question. It turns out, clinicians have come up with some pretty clever workarounds to solve this very puzzle.
It's this really smart two-step process. First, they test for an enzyme called beta-lactamase. Think of it as a defensive shield that some bacteria use to break down antibiotics. If that enzyme isn't there, and the bacteria is already susceptible to plain old ampicillin, then bingo, they know the combo drug is going to work. But what if the enzyme is negative, and the bacteria is still resistant to ampicillin? Well, that's a clue that they're dealing with a different kind of resistant strain, known as BLNAR, and in that case, they know to avoid this antibiotic altogether. It's a fantastic example of real-world clinical problem-solving in action. So, as we wrap up our little investigation here, what's the big takeaway from this whole mystery of the missing breakpoint? Well, it really all comes down to one simple but powerful idea: accuracy over availability.
So let's recap the whole story. The science got better. The gold standard test was updated based on that new science to protect patients.
The quick estimator test couldn't keep up because there wasn't new data to recalibrate it. So, to prevent any chance of incorrect treatment, the CLSI intentionally removed the old, unreliable data. At every single turn, the priority was clear. Patient safety comes first, way before just having a number available on a chart.
So you see, the missing breakpoint wasn't some mistake or an oversight at all. It was actually a sign of a system working exactly the way it should. It was science rigorously correcting itself to make sure patients get better outcomes. And it leaves us with a final thought to chew on. What other blank spaces in medicine aren't signs of failure, but are actually signs of progress?